The only thing that evolves faster than technology is our expectations. We want everything. Better, easier, now. Suddenly, downloading an app feels like it takes forever. And in many parts of the world, data is still at a premium, with 1 megabyte costing up to 5% of a monthly wage. Let's face it though, until now, the alternative to native apps hasn't been great. But that was then. Progressive web apps can now deliver mobile web experiences with a native look and feel, offering features like real-time push notifications, adding a site to your home screen so you can easily jump back to it with a single tap, even when you're offline. Plus the ability to make quick payments on the go. And all from your browser. This is the next generation of the mobile web. So what are we waiting for? Let's go and build something great.
Good afternoon, everyone. Can you all hear me? Yeah, okay. Good afternoon, everyone. I wanted to start with this video to get you all excited about the future of web apps. And hi to everyone watching from the overflow room. My name is Jad Joubran. I'm a full-stack teacher in Amsterdam, Brussels, and Lisbon. And I'm here today to talk to you about the future of web apps. And to talk about the future of web apps, we have to talk a lot about progressive web apps. So I'm going to cover progressive web apps from scratch, like a small introduction. And then I'm going to talk about some of the best practices that we know for modern web apps and for PWAs. And then we're going to talk about modern web APIs and finally conclude with the future of the web. So let's start with PWAs. How many of you know about PWAs? All right, great. So I'd like to introduce PWA to say this is an ongoing effort or solution to solve the pain points of the web and especially the mobile web. Because you know how slow the mobile web is. And the first main component of a PWA is the web app manifest, which is a JSON file, and you link to it with the link rel manifest. And then this JSON file tells the browser more about your application. So you can define like key values, for example. If you're building a Photos app, you can give it a short name, Photos. If you have a longer name, you can specify it here, or it can be the same. You also specify a theme color, which is going to theme your app in the status bar and once you go to the task switcher. You also have the ability to customize the splash screen color with the background color. You also provide an icon. And you can also provide a start URL. So when your users click on the icon on the home screen, what is the first page they're going to see? And display standalone actually does a lot of magic. This is the one that hides the browser URL and all the navigation. And finally, orientation is mostly natural, so you don't have to specify it, but you can also lock it to portrait or landscape. So with this particular manifest.json, this is how your users will be able to add your app to their home screen. And once it's on their home screen, if they click on it, you'll see a splash screen. And this is the start URL that you chose. I'm sure most of you are familiar with these. So let's get going into the second main pillar, which is service workers. And the service worker is a script that is run by the browser in the background and separate from a web page. So let's take a look at how traditional requests work. Say you have your web page and you have the internet. And the green dot is the request, which goes from the page to the network, and this is the request, and then you get the response back. But once you install a service worker, this acts like a proxy. So this allows you to intercept network requests when they're going, and then maybe do some magic things with them. So this is the basic for service worker. And this actually unlocks tons of new possibilities, and mainly the ability to make our app work offline, to receive push notifications, and also to do background sync. So why do we have service workers? If we go back a while and if we take the example of Facebook and the screen, Facebook doesn't have a service worker. So if I'm offline, as you can see, and if I click on Facebook, the network request is going to go to the internet, but then simply fail. And it fails, and we have nothing else we can do about it. So that's why we need service workers, because we want to have some secondary strategy. So let's go ahead and install our first service worker. So first of all, let's make sure this browser supports service workers. And then we'll use the navigator, the service worker, and register our service worker.js file. Now, the location of this file actually matters a lot. In most of the cases, it has to be at the root level, because if you put it inside a subdirectory, you will only be able to control requests going out of the subdirectory. And then this is a promise, so you can resolve it, or you can see if it's thrown an exception. But what do we have inside the service worker.js code? Well, it's regular JavaScript, so we're going to listen to the install event, so when the service worker gets installed. And then we're going to create a cache and call it precache v1. And inside precache, I'm going to add all of these static assets that are important for my page. So for example, index.html and the logo.png. So what happens now, when the service worker gets installed, I have these two files in my cache. So now the next logical step is to listen to the fetch event. And the fetch event fires whenever your main page requests anything from the internet. So now we're able to intercept those fetch requests. And we're going to say, like, I'm going to respond with, but then we have a conditional here. Do I have this request in my cache? If I have the request in my cache, then the response is going to have the actual response that we need. So we'll immediately return it. But if I don't have this in my cache, then I'll use the new fetch API to get it from the network and then return it back to the page. So this is the kind of power you have when building service workers. And this is how you build service workers, but please don't do it. This works, but it's not production ready. The first example I can tell you why this is not production ready is because if you want to ship an updated version of your logo or of your index.html, then it's not going to be very efficient. You'll have to clear the cache, you'll have to create a new one, maybe change cache v1 to cache v2, a lot of things that don't make a lot of sense and are not typically optimized. So that's why you can use Google Chrome's node module called SW Precache, which does exactly the same, but you can simply configure it using a configuration file. So what I've done here is exactly the same. I said my important static resources are index.html and everything inside the images folder. And then you run this binary, and you run this, command, and you pass in the configuration file to it, and you have the service worker.js file ready for production. This actually works, and you can use it. So now let's see how this reflects to our previous graph. Just to recap, this is a network request, and this is the response without any service worker. And once you install a service worker, you will see that the network request is going to go to the service worker, and then we realize we have this in the cache. So let's bypass the network altogether and return the response to the page. So let's go to Chrome DevTool, Network tab. The first time a user visits your page, or before having a service worker, you can see that the index.html and the images have a size, which means they're being fetched from the network. And why this is okay, if you have a bad network connection, they might not load, or they might take forever. So once you have a service worker installed, you can see you are able to ship them reliably and consistently, regardless of network connectivity. So you can always ship those standard assets, which is very important. But that's only half of the way there. Because after you've shipped these important files, you actually have like an API request going to a weather API, going to your own API. So this is where Google Chrome, again, SW Toolbox node module comes in handy. So SW Toolbox gives us dynamic caching strategies to deal with those APIs. Typically, you've got three. So you've got cache first, which means if you have something in the cache, let's just go ahead and read it from the cache. Network first, which means go to the network, get the response from the network. But then in case it fails, then we'll use the cache as a second option. So go to the network, but if it fails, revert to the cache. And this makes a lot of sense. I want to read something from the API, but in case there's no internet, I will not show a 404 or a dinosaur page. I'll just show what I have in the cache. And fastest is quite interesting because you will raise two requests, one to the cache and one to the network. Typically, the one from the cache will return first. So you will get a fast response, and at the same time, you will keep an updated version in the cache for the next time you use it, because the network response is going to take some time and then update the cache. So how do you use this? So which one should we use, actually? You're going to use multiple ones. You can say, for example, for this route, or for this path, or this regular expression, if I'm loading the orders from my API, I want to use the fastest strategy. If I'm loading the list of countries, I want to use the cache first strategy. And you can also further customize these. So you can have a maximum age seconds. So you can expire all of these after 1 day. You can also add a maximum limit or maximum entries. I really love this one because it prevents Li-Fi. Li-Fi is when your phone thinks it has Wi-Fi, but it doesn't. And you could end up waiting on a request for like 1 minute because your phone thinks it has Wi-Fi, but it actually doesn't. But you can set a network timeout seconds and basically says, if it takes more than 6 seconds to load this request, screw it, I don't want it from the internet, I'm going to get it from the cache. Now, the question is, you probably want to use SW precache and SW toolbox together, and it's as easy as adding the runtime caching to the same configuration file. Has anybody used SW precache toolbox? All right, so there's actually a newer version of them, which is called Workbox. The reason why, so you can use SW precache and SW toolbox today. A lot of major websites are using them in production. For newer projects, you might want to consider Workbox, which does exactly the same thing, but it's typically more modular, so they focus on modularity, and they give you lower level recipes. So you can typically do a little bit more with it. And it has been launched, I think, about a month ago. So after doing all of these, we have the app install banner. And typically, if a user searches for your progressive web app, if they go to Google, for example, or if they simply land on your website, the browser might ask you, like, would you like to add this to your home screen? So this is something that we cannot control yet. I think it will be changing soon, but it's not 100% confirmed. The only thing you can do right now is defer it. So Flipkart, for example, defers it until you check out or until you buy something from them. Now, when does the browser decide to show this? First of all, you need to have a valid web app manifest. You must have a registered service worker. Of course, you must be on HTTPS. Service workers don't even work on HTTP. And there's an engagement check. So Chrome will typically not ask you from the first time, but it's not very clear at the moment. It used to be 5-minute difference between two visits, but it's changing a lot. But anyway, for us developers, if you want to test this, there's a Chrome flag to bypass the engagement check, and you'll be able to test it without worrying about the typical engagement check. And there's the background sync, which is a very exciting feature, actually. You can, with this code, defer tasks until the user has connectivity. This particular piece of code only works on Chrome at the moment, but if you're building a chat application, you can let your users send their message, close your app, your web app, close Chrome, and as soon as you have internet, it will send it again. So this is the kind of thing you want to send a message, and it will wait for connectivity and employs an exponential backoff. So it will try after 1 second, then wait more, wait even more. And then there's periodic sync, which is currently being spec'd, so it doesn't work on any browsers yet, but basically lets you pull something in the background every 5 minutes, for example. You don't have to provide a power state or network state, but this gives you finer control, like if you want to have the user plug his phone or use Wi-Fi. So I'm sure you're all wondering about the browser support. Let's see what we got. So everything works on Chrome, also on Firefox, also on Opera. Samsung Internet also shipped it, and they also shipped it on Android, actually, on Pixel devices and Nexus about a month ago. In Edge, it's in development, and in Edge 15, you can see service worker support behind the flag, which is pretty exciting. And in Safari, there's just a brief positive signal for the next 5 years. So there are some things you can do for iOS. There's this meta tag, which kinds of work like the manifest title, name, I mean. So you can provide the name in the head. You can provide this proprietary meta tag to enforce a name. And you also have the ability to let users on Safari add your website to the home screen and even show them a full screen experience. I think this has been around for like 4 or 5 years. But I say proceed with caution because you might have some performance issues. Some users have reported performance issues with a mobile web app capable. And the problem is on iOS, there's no hardware back button. So if you don't test on iOS, your users can get stuck in the app just forever. So make sure to test on iOS if you're going to use the last two. So now that I got you excited about progressive web apps, let's talk more about some best practices. And you see PWA is in between parentheses because these best practices can be used regardless if you're doing a PWA or not. So that's because actually PWAs promote best practices. That's why they have better UX and they have better engagement. So the first thing I want to talk about is the theme color. And the theme color is what you can see in the green on top of settings. So you can see we can actually color the URL bar into green. And to do this, this doesn't have anything to do with the manifest.json. This is actually the theme color that you specify in the head. So typically, you will have the same color here as the manifest.json. Then the important thing is to ship something on the screen, visible on the screen, as fast as possible. And this is what we call the first paint. So you want to have the first paint to happen as soon as possible. And typically, if you have unoptimized rendering, your users will be waiting on a widescreen for far too long. Whereas with progressive rendering, you will be rendering you're rendering pixels to the screen as fast as possible. So, and from a network tab perspective, this is unoptimized rendering and optimized rendering, and I highlighted the time when the browser starts rendering. So you want to make it as fast as possible. And last year, on the same stage here at NDC, I presented a very similar section. But this year, I'm going to show you how to do it in a modern way, how to do it in 2017. So first of all, we still have to inline the critical CSS in the head. So you want to find the most important bits of your CSS and put them in the head, because CSS is blocking. And then we want to asynchronously load the rest of our CSS, but you cannot use a regular link rel style sheet because this is going to block rendering. So what you can use actually, you can use the link rel preload. Has anybody used it? Yeah? So the link rel preload actually preloads those assets without blocking. So I'm going to preload the app.css. You have to say that this is a style. And once it loads, this will typically be the style sheet. This works on Chrome and should be coming soon to other browsers. But in the meantime, you can use the load CSS script and polyfill, which is very tiny, so you can also inline it in the head. And for JavaScript, it's still the same. You have to unblock JavaScript by using the async attribute. Now, if we take this step, this thing a little deeper, we can talk about the app shell. And the app shell, if you think about it, is just the minimal HTML, CSS, and possibly JavaScript that you need to power your user interface. So a diagram of it would be this. You have the application shell on the left, and then once the content is ready, to just go inside the application shell. This is a pattern we see a lot on native apps. And once you inline your CSS, it's actually very easy to do an app shell as simple as this one. And it doesn't need so many lines of CSS. You can actually do it in about 30 lines of CSS. So the app shell typically should be inlined in the head. And what I want to tell you about the app shell, it's about critical code. So think about the app shell as you want to prioritize the critical HTML, CSS, and JavaScript. So if your app shell has a burger menu which toggles a sidebar, make sure that the JavaScript of this burger menu is inlined. Because if it's not inlined, your users will see this burger menu, click on it for 10 seconds, but its code wasn't actually prioritized. So that's how you should be thinking about the app shell. Another important piece of information is to delay service worker registration. So let's see why. When your users visit your website for the first time, we're using the optimized rendering technique that I showed you in order to ship something fast on the screen, along with the app shell strategy. But once they are on subsequent visits, so once they visit us the next time, if we have service worker support, then we have service worker that powers our page. So we shouldn't worry a lot about subsequent visits, but we should worry for now about first visits. And what actually happens with the snippet of code that I showed you, which registers service worker as soon as possible, is that we're not allowing the browser to prioritize everything it needs to have a very nice first visit experience. You can see this because we have interleaved requests. One of them are used for the service worker, and one of them are used to show the user a nice first visit experience. So all of these service workers are actually slowing down the first visit. So what we want to do typically is defer this until the page has loaded. So you can typically wrap it with a window add event listener on load. And once you do that, you can see how clear it is that you're prioritizing all the 3 requests that you need in order to ship the first experience. And then after this has finished, once the user is reading your content, in the background, you'll be able to install the service worker. But most of us are using JavaScript frameworks, which means if you're using a JavaScript framework, you have to wait until your framework has booted. Or else, if you do it on load, then you will also be erasing your framework. So if you're using Angular, make sure to put it in a callback once Angular has finally booted. And a typical question that I get is, how do you detect that a user is coming from the home screen? How do I know, using analytics, for example, that this user is coming from the home screen? And I saw a lot of recommendations on the web to just add query string home screen equals 1. But this actually ruins the work offline experience that you have. So a lot of PWAs, I added them to the home screen, and then if you go offline, they actually don't work. And the reason behind it is because the start URL, index.html query string home screen equals 1, is a completely different URL than index.html. So any URL with any different query parameter is considered a different URL. So you'll have to cache it, and you have to further customize SW precache. But I was giving a very similar talk in Bucharest a few months ago, and one of the attendees told me, like, why are you complicating it? Can't you just put a hash home screen? And in 90% of the cases, you can just put the start URL to be hash home screen, and it works. In case it doesn't work for your scenario, then you can make it a bit more complicated. If not, you can simply use the hashes, and it will work. You'll be able to read it in JavaScript. So to build PWAs, we need to have debugging tools, and thankfully we have a lot of them. The first thing that we have is Chrome DevTools. In the Application tab, you have the Manifest subtab, and this reads your manifest.json, warns you against anything that doesn't work, and you'll be able to see if you're missing any important piece. For example, this is the manifest.json from Twitter Lite. And if you click on Service Workers on the left, you can also inspect service workers. You can trigger the offline state. You can force update this service worker or delete it. An important thing as well is you can trigger a push event or a sync event. And you can also use update on reload and bypass for network once you're developing. And there's a companion that you can have if you're building progressive web apps, which is Lighthouse. Has anybody used Lighthouse? Yeah? So Lighthouse gives you performance metrics, accessibility, best practices, and PWA tips. So this is the ultimate guide or ultimate help that you can have once you're building PWAs. So make sure to always be testing against Lighthouse, because it will tell you that for your UX perspective, you're not, for example, showing anything on the screen before 2 seconds, and you need to fix that. It will give you tons of tips. And it's also available as a node module. So if you have continuous integration, you can actually have performance regression or UX regression using Lighthouse. And good news is that it's coming in Chrome DevTools as of Chrome 60. So if you go to Canary right now, you will be able to run Lighthouse from Chrome DevTools. Now, let's imagine for a second that your users have added your app to the home screen. This is a big pleasure. And there's actually a lot of responsibilities behind it because your users have high expectations for this. So if you are building a PWA, you should realize that, or you should think that it should have native-like performance. Because first of all, users might not know that the term PWA exists at first. Second of all, it's on the home screen, so it must be fast. It's not inside the browser anymore. And a typical question that I get is like between quotes, like, can I make my website as a PWA? While this is technically true, you can make any website as a PWA. It's probably not a good idea if you have a lot of JavaScript or if your experience is super slow. So what you can do instead, what Twitter did, they took a progressive approach and built Twitter Lite from the ground up, step by step, feature after feature, which was one of the most successful PWAs. And the reason why I'm telling you this is because even if you're able to ship the app shell really fast, under 1 second, if your users are waiting a lot, then they're not going to have a pleasurable experience. So after the app shell, you have the first meaningful paint, which is the first time you see actual content or meaningful content on the screen. But once again, remember, you probably cannot click on it yet. If you click, nothing happens, because your main JavaScript is still rendering. So this is a real trace I took on my MacBook Pro i7 using only 5 times CPU throttling and 3G network throttling. So you can think simulating a network device, a mobile device. And you can see we're waiting about 8.5 seconds to parse JavaScript. You know, this is a lot of time. So this is the problem when building PWAs. And the most important thing is not to ship too much JavaScript. But I know this is not easy. So I know this is one of the hardest things that we have when building real apps. So I'm going to give you some tips that you can use to actually help you ship less JavaScript. First of all, Source Map Explorer, which is a node module that lets you explore and understand what vendor.js you're shipping. So this has helped many people realize that they're shipping 2 versions of the same library, for example. Or they help them realize that they're shipping the entire Lodash library, but they only use 2 methods out of it. So this will help you a lot understand what kind of JavaScript you're doing. Another thing you must do for big applications is code splitting. So instead of shipping a huge app.js, you can actually ship smaller JavaScript files depending on what kind of experience the user is asking for. So if the user goes to settings.js, to the settings page, you only ship the settings.js file. You don't have to ship the entire app.js. And a nice tool that just landed in Chrome, so you have this on regular Chrome now, on Chrome stable, I mean, is code coverage. And you're able to record and open a web page, interact with it, and you'll be able to see how much of your JavaScript and how much of your CSS is not being used. So this is very important as well to be able to optimize for this fast loading experience. So make sure to give it a try. Just do Command-Shift-P inside Chrome DevTools and select code coverage, coverage, and you will have it. And then there's also another thing I've been experimenting on, which is called conditional polyfill loading. And I've published a small library which is called Promifill. It's less than 500 bytes, so less than 500 characters. But it actually lets you conditionally load polyfills only when they're needed. Because I realized a lot of frameworks and a lot of people are shipping polyfills for all the users. Whereas you have Chrome and Safari, for example, they support web components out of the box, V1, and they support a lot of new features. So here's how you can use it. You just call the Promifill method, and you give it a test. So is fetch supported in window? And it allows you to actually use your own polyfill. So you can choose whichever polyfill you would want to use. And then this is a promise. So one note is that this depends on promises. If you want to support Android 4.3 or IE8, you'll have to ship a small promise polyfill. And then once you resolve this promise, you're guaranteed that you have the fetch method. So you'll be able to use fetch on all browsers. And this makes a lot of sense to use with fetch, because right now fetch works across all devices. But you're surely gonna have users that are on one Safari version older than the latest one. So this makes sense because all users have it except for just a few. And the way this works is that for users with fetch support, you see we have the index.html, app.js, which uses fetch users, and it immediately runs. Right after we load app.js, we're loading the users. But for users or browsers without fetch support, you can see they take a small hit. It's not very small, but they actually take a hit of loading the polyfill. So polyfill will actually block for users without fetch polyfill, but it doesn't break, so it will actually make it work. This is one of many solutions. You can also use polyfill.io, which have a CDN service. Now, once again, this is all from a low level or from the ground up, but you're all using JavaScript frameworks, and this makes a lot of sense, or libraries as well. So I crafted a list of things that you need to look for once you're choosing a JavaScript framework. The first thing is you want to have a smaller bundle size, because if you're starting with, say, 100 or 150 kilobytes of JavaScript, your headroom is almost gone, so you cannot really build a nice PWA experience. Second of all is the ability to code split, because as your app goes bigger and bigger, no matter what framework you're using, you will have a big JavaScript bundle. But if you're able to do code splitting, then you're able to ship only parts of your application only when they're needed. And platform leverage is also something very important nowadays, because all browsers have, most browsers have excellent browser support, feature support. So just like I told you, fetch works everywhere. So when I say platform leverage, it means you should not be shipping code to make fetch work. Okay, you should ship polyfills, but conditionally. So this is why I talk about platform leverage. So use those web APIs whenever they work. And whenever something doesn't work, you can use conditional polyfill loading. So I'm going to talk about 4 or 5 of the top of the most used frameworks and show you how you can build PWAs. So for React, about 3 weeks ago, Create React App now supports a PWA out of the box. So once you run this command, you will have a PWA React app out of the box, which is great because you don't have to worry about configuring anything anymore. Anybody knows about Preact? Yeah, so Preact is a 3 kilobyte alternative of React with the same ES6 API. And it's really nice because so many people have migrated from React to Preact by just changing some configuration. And using the Preact CLI, you can also create a new PWA out of the box. And that's really cool. For Vue, if you're using Vue, you can use the PWA template, and this will also generate a PWA. For Angular, there's a -- mobile flag, the mobile flag, which is temporarily disabled, but they're actively working on it. Once this works, the mobile flag works again, you will have service worker support, manifest, and even more push notifications. But this doesn't work at the moment. So what you can do at the moment is build for production with ahead-of-time compilation. And then precache is a command that I created, so this is not something that works. But inside this npm script, you can actually just run SW precache, generate the service worker, and everything we've done in the beginning. And for Polymer 2, you can also run Polymer init and then select the PWA template. And what I like about Polymer 2 actually is that since you have Safari and Chrome, which are the leaders on mobile, they all support Web Components v1, which means for Polymer 2, you're only going to ship 11 kilobytes as a framework code for these two browsers. On Firefox, it's going to be bigger, so they're using conditional polyfill loading. On Internet Explorer, it's going to be even bigger. But it means on mobile devices, you're able to ship, you have more JavaScript to write, because the framework, Polymer 2, is only taking about 11 kilobytes. So that's all for progressive web apps. Now I'm going to show you some modern web APIs that, once again, you can use them with or without PWAs, but they make sense a lot in the modern web. And the first one is improved scroll performance. So previously on the mobile web, scrolling was super, super slow. And there's a reason behind it. It's more like how the browsers work. But right now, you can fix it by, whenever you have a touch start event, you can add the passive true flag. And what this means is that, actually, let me tell you why it's slow. Once you add the touch start event, the browser has to run all your callback to see if you called event.prevent default. So the fact that this touch start event is cancelable is really slow, because the browser has to wait, see if you called event prevent default, and then afterwards it will commit it to the GPU. But once you have passive true, it's like you're telling the browser, I'm not going to call event.prevent default. And then the browser is able to immediately commit this touch start event to the GPU. And even if you call it, it's not going to have any effect. So this works on Chrome, Firefox, Safari, and Opera. And actually, the newest version of Chrome on mobile started doing it by itself. So you don't have to do it for Chrome, but you still have to do it for all other browsers. You can also defer non-essential work using the request idle callback. So if you're doing some analytics work, you don't want to run this right at the vsync, right when the browser is drawing on the screen. So what you can use is request idle callback, which gives you small chunks of work that you can do right before the vsync. And this makes sure you don't go over your frame budget. So you're able to always ship at 16 frames per second, or 60 frames per second. Intersection Observer is quite awesome as well. It's only on Firefox, Opera, and Edge at the moment. And Firefox support is coming soon, so it's the next few releases. Intersection Observer allows you to ask the browser for the visibility of an element. So you can see how much of it is intersected with this viewport, for example. So this can be used for lazy loading images, especially if you're building something like Twitter or Tumblr. So you only load those images once they're visible, or even with a top margin, say, of 200 pixels. You can also do infinite scrolling. But this is not meant for parallax. I'm glad they designed it that way. And there's also CSS containment. So typically on the web, if you change the width or the left or height or margin of one element, the browser has to reflow or recalculate the layout of the entire page. So on big pages, it can be quite expensive. You can see it takes about 56 milliseconds just for changing the width of an element. But with CSS containment, you can contain the layout of an element to a particular element, which means if you have like a widget and if you change the width of this widget, it's not going to reflow the entire document. It's only going to have the layout route to be the box itself. And this went down to 0.04 milliseconds. And this actually makes a lot of sense with web components. So once you're building a web component that's completely isolated, you can give it a containment of layout, and then it's not going to have any side effects on the entire page. Also, the payment request API, which you saw in the video, allows you to do payments on the web. This is not a payment processor, so this only gives you a native payment sheet on the mobile. Great news is that it works on Edge at the moment, and Chrome is shipping it across all devices. So you'll see this soon on the web, Android, iOS, macOS, desktop, Windows, even Ubuntu, even Linux as well. And then there's this amazing web share API, which doesn't work anywhere at the moment. It used to work for the last 6 months as an origin trial. Does anybody know about origin trials? All right, so let me explain. These are quite interesting. So you all remember the WebKit prefixes, the Moz prefixes. So in order to avoid all of these issues, right now experimentation on the web happens through origin trials, which means if you want to test a particular feature, you have to sign up for it and add a meta tag which expires on a certain date. And they also have a check to make sure that it doesn't get activated for more than, for example, 0.5% of global users. This is a great way to have experimentation on the web without having a big website such as Facebook or Google require us to proceed with a certain feature because they used it and they have a lot of traffic. So WebShare API was being tested for the last 6 months. If you use Twitter Lite on mobile, they used to use it. And it's as easy as calling this method. And you will have the native sharing UI from Android. And it's really cool. So I've heard that there was really good feedback for it, so I think we should be seeing it soon across browsers. So all of this is really exciting, and now I'm also going to talk about some things you should expect in the coming few months or coming few years. And the first thing is improved add to home screen. So this is coming to Android, and I'll show you this video. If you enable add to home screen flag and you add something to the home screen, it's going to take a while. That's why it's behind the flag. But in the background, this is using Web APK to install a native APK as a PWA on your phone, which means even when you close everything, and even if you remove this home screen icon, it's an app. So you can find it in your app drawer. You can inspect it. You can see the app info, and you can uninstall it. So this further blurs the line between native apps and progressive web apps, which is really exciting. So just as a recap, this doesn't work right now on Chrome. If you want to test it out, you can enable a Chrome flag, which is improved add to home screen. And as soon as I heard about PWAs, I thought that they actually make a lot of sense on desktop. And we're starting to see things, PWAs on desktop. First of all, on Chrome OS, which can also be tested on your own Chrome, if you enable the add to shelf flag, is that if you go to a PWA, the browser will suggest to you on a desktop, would you like to add this to your shelf? And if you add it to your shelf and click it and open it, it's going to open without the browser UI, which is really cool. Also, Windows 10 is doing this out of the box in the next version of Windows 10, in the next update. This is what they mentioned in the Build conference last month. And something very exciting is that the Windows Store is actually crawling the web, looking for PWAs, and adding them to the store. So Windows users will be able to look for PWAs, and they don't really know they're PWAs. They just search for apps and then click install. And installing them will be super fast because typically you're just installing index.html file. So that's really cool. And how many of you have heard about WebAssembly? Yeah, quite a lot. So you know what WebAssembly is. It's a cross-browser, low-level language that's designed to run native C or C++ code in a tiny binary format. Just these 2 weeks, you're starting to see a lot of websites use WebAssembly, especially Figma, which runs a sketch-like editor in the browser. They also saw massive performance benefit on browsers. It's still not very stable. They're having some issues on some browsers, but it's really promising. So here's an example of a WebAssembly method, which is called add2, that just adds two integers together. I know it's not super exciting, but that's the code for it. So it's tiny. And I'll show you how you can use it. And you can see I showed you all the browser icons here because it's shipped across all browsers. Some of them have it behind a flag, but the minimum viable product of WebAssembly is actually out there. So I'm going to use async await functions just to make it more tidy. So first of all, you fetch the binary, and then you need to create an array buffer out of it. Then you need to create a module out of it, and then an instance. And then if you console log instance.exports, you will actually have a native add2 method. So you'll be able to run the add2 method at almost native performance. Right now it's 1.2, but it's going to become faster later on. And what this means, it's not that we're not going to write JavaScript anymore. What this means is that the future app model, I think, is that you will have a PWA communicating with WebAssembly to do things that we've never thought we're able to do. So your PWA will be able to do image and video editing, which is happening right now with Figma, image recognition, encryption, and a lot of other things, just because we have WebAssembly. So did I get you excited about PWAs and the future? Yeah? All right, so I have a call to action for you, and I want you to get even more excited. And first, there's an annoying thing, which is I went to speedtest.net a few months ago to test my connection speed, and I was roaming, and they were like, thank you for visiting our website, but just download our app because we don't know how to do it on the web. And this really sucks, especially right now. Why do you need to install 20 megabytes to test your internet connection and have an app take your memory or take your storage for 6 months if you're never going to use it? So this is why the web is awesome. You want to do something, you just go to the URL, do it, and then you're done. So my call to action for you is, if you really like this stuff, go ahead and build your first progressive web app. And the strategy you can take for this is, regardless of what your business logic is doing, regardless of what your company is doing, start from scratch, forget about frameworks and forget about your business logic, and focus on best practices, and you will have something up and running. And as soon as you have something with a decent experience, then you can add your business logic. And of course, if you want to use a framework for work, it makes sense, or a library, then you can start from scratch using this framework. And don't forget that to always test on real mobile devices, because what takes a fraction of a second on your laptop can take up to 5 seconds or even more on a real mobile device. So you cannot really compare to an i7 MacBook Pro. So what you can have is always plug your Android and have Chrome, or plug your iPhone and have Safari to inspect and see how it's working on a mobile device. And if you're not able to do that, or if you want to do more frequent tests, you can use throttling features in Chrome. Throttle CPU down to 5 times, and for internet, you can use regular 3G if you want to simulate what it's like for real users. So nobody would build a PWA if they haven't seen successful stories, and my favorite PWA is mobile.twitter.com, or just twitter.com on mobile. I uninstalled the native app a few months ago, and I'm simply using twitter.com. It's amazing. It also works on iOS with all the best practices, but without actually being a PWA. You can also check Wigo, which is built in Polymer, and Flipkart, which is built in React. And don't forget that PWAs are one of many other solutions that tackle similar problems. Problems of large app sizes, network connectivity, network size restrictions. So Android instance apps also solve a similar problem, but from a different perspective. And also Android Go, which was announced last month at Google I/O, which is like a smaller version of Android that's meant for smaller devices. So these are all different solutions. It's not like after 2 years we're only going to have PWAs, or we're only going to have instant apps. They just tackle it from a different perspective. So if you want to see my resources for the talk, make sure to go to Google Web Fundamentals and Mozilla Developer Network. And I collaborated with Nicole Saidi, who's sitting over there. She's going to give you a Designing Great Progressive Web Apps talk. So we made sure that there's no overlap. So this is a complimentary talk, and she's going to focus about user experience. And it happens to be in the same room. But if you want to watch her, make sure to rate my talk outside. So I really hope you enjoyed my talk. You can find my Udemy course on this URL. It's called How to Become a Better Developer. And you can find the slides over here, and I'm happy to answer your questions. Thank you for your time.